bicycle dynamo. Okay, we have seen here vessel-like structure which is fitted very close to the tire. So whenever the tire rotates, this cap also rotates. Okay, dynamo ko cap pani ke garcha ta rotate garcha hai. Like you can see here, this is the actual structure. यहाँ चाहिँ त्यो magnet छ र coil छ है. Now let's go to this another video.
Students, you might have seen a bicycle dynamo. In the bicycle dynamo, the copper coil of wire is fixed around the magnet. While rotating the bicycle pedal, the magnet moves inside the dynamo, and thus electric current is produced. The electricity thus generated is used to glow the headlight of the bicycle.
Very short and sweet, yes, of dynamo. हामीले पढिसकेकोहरु हो नि तिनीहरु हैन. Now let's go to the alternating current and direct current. Alternating current means whose polarity changes with time. Okay, यसको direction change भइराख्छ alternating current को, and direct current its polarity doesn't change with time. It always remains same from plus to minus भइराख्छ. तर alternating current एउटा छ नि crest and trough. एउटा crest र एउटा trough ले one versus its direction with time. Like you can see in this picture, you can see here, यहाँ हेर त पहिला सुरु यहाँ प्लस छ यहाँ माइनस छ र सेकेन्ड पिक्चरमा हेर त यहाँ माइनस छ फेरि प्लस छ. डिरेक्सन इज चेन्ज्ड. फर्स्ट डिरेक्सनमा चाहिँ आई बाट रेजिस्टेन्स तिर आइराखेको देख्छौ आर, अनि आर बाट फेरि घुमेर आई तिर जान्छ. सेकेन्ड पिक्चरमा हेर्यो भने आर रेजिस्टेन्स हुँदै हुँदै आई तिर करेन्टको डिरेक्सन गएको देखाउँछ है. सो दैट करेन्ट रिभर्सेस डिरेक्सन इन इक्वल इन्टरभल अफ टाइम है. current changes its direction, but in direct current, if you see the picture, what do you see here? Current is always flowing through the same magnitude. Okay, now you can see the current is flowing in only one direction. Current every direction मात्रै यसरी flow गरिराखेको छ नि, I to R. So that polarity doesn't changes. Polarity remains same. But here in first picture, positive polarity, in second picture you can see the negative polarity. Okay, so direct current doesn't change its direction, but alternating current changes its direction. If you see this video, you will understand it clearly.
Hi there, I'm William Mack coming from our Cake Lab in Fort Lauderdale, Florida. Did you know that you use two forms of electricity every day? Alternating current, or AC, is what comes to your home from your power company. Direct current, or DC, is what your phone or TV remote uses. And anytime you see a power brick or wall charger, you actually have both, because those convert AC to DC. But what's the difference? And why do we have AC and DC? I'm glad you asked. It's not because engineers make things complicated. There are actually really good reasons. Let's start with DC power, because it's pretty straightforward. With DC power, the power supply provides a constant voltage. For example, USB outputs a steady 5 volts. The current only flows in one direction, from negative to positive, even though the amount of current can change depending on how quickly we want the USB device to charge. Now let's talk about AC power. Remember that the A in AC stands for alternating. That's because the flow of current switches direction, or more specifically, alternates current. This is the type of electricity that flows into your home. In the US, the voltage cycles between plus and minus 120 volts at 60 hertz, or every 1/60th of a second. And because current is proportional to voltage, the current also alternates between positive and negative. You can also see this by looking at how current flows. With DC, current flows from the positive side of the supply to the negative side. With AC, the current flows back and forth. So we covered how AC and DC work, but there's still the question of why we have both. If you want all the details, look up the War of the Currents. At the simplest level, we use AC power because it can be easily stepped up or down using simple transformers. By stepping voltage up into the hundreds of thousands of volts, we can transmit the power at a lower current, and this reduces the amount of power loss and transmission. The voltage is then stepped back down into a more usable range of hundreds of volts that can be used in our homes. Meanwhile, DC is used in a majority of modern electronic devices. That's why most devices have a power adapter like this one. It takes the AC power in your home and converts it to DC power that your device needs. These devices might use or generate AC signals, but they operate from a DC supply. One reason is that transistors, the building blocks of integrated circuits, require a DC voltage. It's also worth noting that batteries output DC power, which is convenient for all of the portable electronics you use. If you want to learn more, visit our newly redesigned Engineering Center
Okay,
website.
Sundar, what is the difference you have found in AC and DC?
Single direction, and this AC flows in both.
Yes,
Direct-
it changes its polarity with times, okay? In Nepal, in 1 second, 50 times, okay? Correct, the direction of the current or the polarity of the current changes how many times? 50 times. Yes, said of US, that is 60 hertz, okay? But in our country, it is 50 hertz, okay? The frequency of current distribution in our country is 50 hertz. It means the polarity of the current changes 50 times. You have to say polarity rather than the direction. Polarity of the current changes 50 times in 1 second, okay? So that frequency of the current distribution is 50 hertz in our country. Now, if you see the next picture I have shown here, diode, okay? This diode is a very small device. You can see in the picture here in blue color, you can see this small structure here. They are the diode. So what does this diode do? Alternating current flows in both direction, okay? But when you keep diode in a device, then it doesn't allow the alternating current to change the direction. It will make the current flow in only one direction. Diode राख्दैपछि के हुन्छ त भन्दाखेरि डायोडले चाहिँ के गर्छ त करेन्टलाई एउटै डिरेक्सनमा मात्रै फ्लो गर्न दिन्छ के जस्तै अल्टरनेटिङ करेन्टको त डिरेक्सन चेन्ज भइराख्छ हैन तर डायोड हाल्दिएपछि के हुन्छ त डायोडले चाहिँ which conducts electricity in only one direction than in the opposite direction. यसले एउटा टर्मिनललाई नेगेटिभ बनाइन्छ अर्को टर्मिनललाई पोजिटिभ बनाइदिन्छ त्यसपछि त्यो करेन्ट चाहिँ सधैँ एउटै डिरेक्सनमा मात्रै फ्लो हुने बनाउँछ डायोडले चाहिँ है तिम्रो बुकमा पनि टेक्स्ट बुकमा पनि तिमीले हेर्न सक्छौ व्हाट इज डायोड भनेर चाहिँ दिएको छ डायोडको सिम्बल चाहिँ यसरी प्रयोग गरिन्छ यसरी एरो गरेर चाहिँ एरोतिर चाहिँ एनोड हुन्छ भने अर्को स्ट्रेट लाइनतिर चाहिँ क्याथोड हुन्छ है प्लस एन्ड माइनस सो चाहिँ स्ट्रक्चरली हेर्यो भने इट लुक्स लाइक दिस स्ट्रक्चरमा चाहिँ यस्तो देखिन्छ है सो डायोड इज अ डिभाइस व्हिच अलाउज द करेन्ट टु फ्लो इन ओन्ली वान डाइरेक्सन है डीसी को जस्तै एउटै मात्र डिरेक्सनमा फ्लो गर्न पर्ने तिमीहरुको कुनै पनि यस्तो डिभाइसेसहरु छ भने त्यहाँ चाहिँ डायोडको प्रयोग गर्नुपर्ने हुन्छ किनकि हाम्रो घरमा आउने करेन्ट त अल्टरनेटिङ हो अल्टरनेटिङले त करेन्ट डिरेक्सन चेन्ज गरिराख्छ त्यही भएर त्यो चेन्ज नहोस् भनेर हामीले डायोड प्रयोग गर्नुपर्छ है अब यो पिक्चर हेर त यु क्यान सी दिस इज द पिक्चर अफ अ सोलर प्यानल व्हिच इज मेड अप अफ बाइ कनेक्टिङ स्मल सेल सोलर सेल थोरै सोलर सेलहरु मिलाएर ठूलो एउटा प्यानल बनाइएको छ इट कन्भर्ट्स सोलर एनर्जी इन्टु इलेक्ट्रिक एनर्जी एन्ड इट वाज युज्ड पपुलरली इन आवर कन्ट्री ड्युरिङ द लोड सेडिङ टाइम लोड सेडिङको बेलामा हरेक घरमा सोलर प्यानल थियो र त्यो ठाउँ जहाँ चाहिँ करेन्ट पुगेको थिएन गाउँमा जहाँ सरकारले चाहिँ इलेक्ट्रिसिटी हाइड्रो पावर लान सकेको थिएन हाइड्रो इलेक्ट्रिसिटी पुराको थिएन त्यो ठाउँको मान्छेहरु कसरी लाइटिङ गर्थे त आफ्नो घरमा भन्दाखेरि दे युज दिस सोलर प्यानल टु लाइट देयर हाउसेस यस so that this is one of the renewable source of energy okay it helps to preserve the non renewable source of energy let's see how does it work कसरी काम गर्छ भनेर हामीलाई वर्किङ प्रिन्सिपल चाहिँ त चाहिदैन है तर हामीलाई चाहिँ व्हाट इज सोलर सेल के हो त सोलर सेल भनेको त्यो डिभाइस हो जुनले सोलर एनर्जीलाई इलेक्ट्रिक एनर्जीमा कन्भर्ट गर्छ अनि यो चाहिँ सानो सिलिकनबाट बन्छ है सोलर सेल इज मेड अप अफ सिलिकन एन्ड सिलिकन इज फाउन्ड अन द अर्थ क्रस्ट हाम्रो पृथ्वीको क्रस्टबाट चाहिँ भेटिन्छ है लेट्स सी द भिडियो
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds. which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses two different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra electrons called holes. Where the two types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons, and location of the positively charged